What we've got here is the inside of the device. This is just, it's not actually quite the configuration that I wanted, but it was all I could produce with the parts that I'd made up. So I mean the real idea will be a similar idea, but then with some pressure points on either side of this pulley to ensure that the rope is well clamped onto that and prevent any sort of slippage. You can see there what I've done is to wrap some sandpaper around this pulley just to help increase the friction. Ideally I'd probably use some sort of rubber tape on all of the pulleys to help grip the thread. All of this is machined from 5mm plastic, 5mm thick, so it's sort of limited in the ways that I could actually produce it. Anyway, it's good enough to show you the idea. On the back of this we've got a magnet holder which holds the diametrically magnetized magnet, which is what's going to give us our reading. So the way that the thread will come in around this guide pulley here and around this pulley, yeah, over that one, which is the measurement cog, and as that's pulled through, that turns the measurement cog. There you go. You can see from the other side of the device I've just put together a crude little reel just to help me demonstrate the thing. What I've done here is to set into the plastic a bearing. There's a similar one behind this pulley, and that helps to give this wheel as good as possible, helps it spin as freely as possible, so that any movement on this rope will move this and it won't get jammed. So that's sort of a low friction bearing there. So what we've got here is the electronics panel. Got 7-segment display here and a couple of buttons just for various things. One of them set up as to execute a calibration function at the moment. The other one's set up to 0 the instrument. We'll just have a look at the back of it. What we've got on the back is a shaft encoder here. Obviously the back of the buttons, and then we've got this interface socket to the development board. You can't see the processor, it's on the back, but that gives you an idea. And all these holes are very accurately positioned to locate with these screws here. And what we've got on the end of this is the magnet set into the end of the shaft, which rotates, and which hopefully this will line up with when it's assembled. So it's good because this whole module, this electronics module, is completely separate from the main assembly, so if that does ever need to be replaced, then it's simply a case of replacing this panel. There's no sort of disconnecting wires and things. So that just slots on there like that. And you can see if I look down at the top now, actually you can't see, it's a bit dark. You can see that magnet is very accurately lined up with that shaft encoder chip there. Yeah, there you go. So now we've got the meter assembled with the thread all fed through. Just plugged it in, and I'm showing a 0 position there. So if I now pull some thread through, this mechanism should start to register the rotations on that shaft, which is being measured by the shaft encoder. Just in there, it's on the end of that shaft, and as that spins with the thread, you can see the reading change. So that's pretty cool. Alright. What we're going to do is to demonstrate that this system can actually accurately measure a distance. At the moment, we've got it zeroed with the knot at the top of that, at level with the bottom of that piece of plastic there, showing north at the moment. So what I'm now going to do, we've got a tape measure here which is level with the bottom of the float. I'm going to let out some cord. Like this. And you can see now that meters reading about 40 centimeters, and the bottom of the cup is hopefully level with about 40 centimeters there. Yeah. Okay, so the next test we're going to do is to take our dip meter and measure hopefully the distance from the 0 point, which I've got defined as having the reel resting on that plank of wood there. You can see the tape measure standing upright from the floor. It's approximately level with this blue mark, which for this particular float, which consists of a plastic cup with some rocks in it, that's where that sits in the water when it's floating. So we've got the tape measure level with that. That helps. I'm not going to move it too much. Well, actually I'll move it to the other side so I can get the bucket there. Right, so that's the tape measures there. What I'm going to do now is move the bucket into position. There. Just put the camera down. Hopefully you can see. And then I'm going to lower this into the bucket and see what reading I get. And you can feel the feedback in the reel as the cord goes slack when that starts to float. So that's measuring approximately 52.2 centimeters from the 0 position. If I bring that back to 0, which was about there, and that's pretty much lined up with the top of the tape measure now. And you can see I'm reading 0.3 centimetres, so it's pretty much exactly back to 0. What we're going to do now is to take our tape measure and measure from the surface of the water down to, well, up to the blue mark. So if I rest that on the surface of the water, which is about there, just try and focus that so you can see a reading. That red mark there is 50, so that's 52. Still on the surface of the water there. Yeah, 52 and a half roughly, I think, or even 52.2 or 3. So there you go.